So question 4, we've got our differential equation here. It's given to us, so we'll just go with that. So the auxiliary equation is m squared plus 4km plus 4k squared equals 0. And what is that? That's going to be m plus 2k all squared, isn't it? M plus 2k times m plus 2k. So we've got repeated roots of minus 2k. And so that means that my answer is going to be x is a plus bt, lots of e to the minus 2kt. So there's that bit. What does that differentiate to give as well, though? So what does that differentiate to give? So I'm going to write that bit down and differentiate this bit. So I'm going to have a minus 2k in front of here, plus differentiate that bit. So just got b and then e to the minus 2kt. And what have we got? We've been given at t equals 0, x equals 0. T equals 0, x equals 0. So putting that in that first one there, I've got 0 here equals a e to the minus 0, minus 2k0, so just a e to the 0. So here I'm getting a is equal to 0. And from the next bit we've got, so this thing here is the speed. So our initial speed is u, and I'm putting a 0 in here, aren't I? So we know a is 0. There's a 0 here, so all of that's just going. Putting the 0 in here gives me b e to the 0. So I've got b is equal to u. So what is that telling me then? So I've got, so that was 0. So I've got b is equal to u. So we've got ut times by e to the minus kt. I think that's that is my answer. That is my answer there, isn't it? Part B, when does it come to instantaneous rest? So basically that's when the velocity equals 0, isn't it, if it's at rest? So I've got 0 equals, we know all of that's 0, don't we? So let's just look at this bit here. B, that's not true. No, sorry, that's not true. We know a is 0, don't we, here? So look, this differentiating, and really I'm just differentiating this again. Or should we do it down here? Let's differentiate this with respect to t. Gives me, write that one down and differentiate this one. So I've got a minus 2k in front of us here. Plus differentiate this one and write this one down. So there's me differentiating product rule here. Take out the factor of e to the minus 2kt, and we know that can't equal 0, don't we? I can see a u in both of those as there, so let's take out the factor of u as well. So I've got minus 2kt from here and plus 1 from there. So this is the thing that must equal 0 at that point there. And so what am I trying to find out? I'm trying to find out what t is, aren't I? So t is equal to, we got here 1 over 2k. T is equal to 1 over 2k. Put that in there and we get the velocity is 0. If the velocity is 0, then it's an instantaneous rest. There we go.